Hey everybody, Mr. Rubo here, and today we're going to look at finding the sum of a infinite geometric series. So kind of leading into that, I just kind of want to show you guys real quick on the calculator. So if you look over to the right there, I'm going to do 2 to the x, just so we can see kind of how that would look. And remember, geometric sequences are in that exponential format. So 2 to the x, when we graph it, you can see as x gets bigger, y goes to infinity. So trying to find the sum of something that goes to infinity that continually grows like this, it's not possible. You're not going to get a sum because it's going to get infinitely larger. However, if I change this to 1/2, oops, helps if I hit the right buttons. There we go. So 1 divided by 2 to the x. And now when I graph this one, you can see as x gets bigger, it actually gets closer and closer to 0. So that idea there is going to help us with today's notes. So switch over, there we go. So if we take the finite geometric series, so the sum of a finite geometric series, it'd be S of n equals a sub 1, slowing down, a sub 1 times 1 minus r to the n over 1 minus r. All right, but now if the absolute value of r is less than 1, so it's that fractional value like 1/2, what that means is if we do the sum as we go to infinity, it's going to be the first term and then 1 minus, now n goes to infinity, but when you raise r to that power, and r being smaller than 1, you end up going to 0, okay, because it's approaching 0 as it gets to infinity. And then you'd have 1 minus r here. So if we simplify this, we'll get a sub 1, so the first term, times 1 over 1 minus r, which we can simplify even a little bit more to just a sub 1 over 1 minus r. So this right here is the equation or the formula for finding infinite geometric series. Okay, so the sum of an infinite geometric series. So let's just do a quick example. So actually with this formula though, it is also kind of, you also have to know that r is going to be less than 1, the absolute value of r. So it could be negative, it could be positive, but it's got to be between 0 and 1 as far as the absolute value goes. Okay, if it's not, then you cannot find the infinite sum. Okay, so real quick, just kind of see an example. Let's say we have sigma from k equals 1 to infinity. So right there, when you see the infinity sign on top of the summation, you know it goes to infinity. But it doesn't necessarily mean that there exists a sum. So with these types of problems, you always want to solve for r first, or figure out what r is first. So r here will be 0.8. 0.8 is definitely less than 1. So that means that the sum exists, so we can use our formula. So s sub infinity, meaning the sum to infinity, is the first term, which the nice thing with this form is the first term is 5. And then it would just be, whoops, and I'm writing it in a weird way. Let me write it in the proper notation. So it'd be a1 on top, so 5, and then 1 minus 0.8. 1 minus 0.8 is 0.2, which is 1/5. So this would actually end up equaling 25. So in this case, as you get larger and larger, like as your sequence gets larger and larger, your numbers are actually going to get smaller and smaller. So that way, when you add them to when you add them all together, eventually you're going to start adding stuff that's so minuscule that it's not going to make much of a difference, right? So you'll get to like 24.9999999, and then your next term will be like 0.000000000001, and it just keeps adding a little bit more, and you get closer and closer to 25. So this is saying as we get to infinity, which we can never reach, but as we get there, we'll actually get to equal 25 for our sum. Okay. Sometimes they will try to see how well you're paying attention, so they could maybe give you a sum like this: 2, 4, 8, 16, ... and actually they want you to find the sum of that. So instead of commas, oops, that's not. Why are we not erasing? There we go. Instead of commas, there'll be plus signs. So, oh man, this thing is going super slow. There we go. So it'd be plus, 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 and then ... So this would be another way of writing an infinite geometric series. The problem with this one, though, is you can hopefully tell r equals 2. So we're just doubling, which means no sum, or not possible, goes to infinity. Lots of different ways of writing it, but there is no actual sum that they will reach. Okay? So yeah, that is geometric series that are infinite. The big thing, remember, is that your r value has to be less than 1. It has to be, the absolute value of r has to be less than 1. Okay? If it's not, it's no sum, no work. If it is, though, you're using that formula. All right? So, thanks for watching, and have a good day.